Today's episode is called Garbage In, False Confidence Out. So, this is the keystone for the whole stack of our governance layer. So, before you mine an agent log, you have to know if you can trust it or not. Because if you have a broken log, it will not fail with an error, it will not fail loudly, it will actually fail quietly, which is much worse. So, let's say you have a fitness score. This is your fitness score. What does this fitness score mean? It means that 94% of your agent's behavior actually replayed cleanly against your happy path, your model. In a review, that's a pass. PM4Pi handed you 94%, you're happy, no problem. There is no warning attached. On the other hand, if you look deeply into your log, and this actually could be done by an AI, this check, but you should do it yourself too to understand this problem precisely. You could find a missing event. You could find course tied timestamps. You have two runs sharing one case ID. You have one activity renamed across deploys. So this is a problem. Why? Because all of these problems did not move your 94%. So the score is confident, it's saying it's precise, and what we are actually having in here is that we're having garbage in and we are having false confidence. So a defective log will not crash your analysis. It just gives you a clean looking number that you shouldn't believe, of course, but you might believe it because it's nice and we humans tend to look at easy things and accept them. So let's look at the problem. The problem is that your number is lying with huge confidence, because even if the quality is bad, you're still getting the same result. So if you look at our pipeline here, you have your event log that goes into conformance checking, and you have your PM4Pi token replay or alignments or whatever that you need here. So that's what happens in this step. And out comes the verdict. Here you have the verdict. But we are making the assumption that actually the conformance checking is treating the log as ground truth. It assumes that every event is actually real, that it is in the right order, it is attributed to the right case. There is no quality check or quality gate on the way for whatever you want to feed to our pipeline. It just takes everything as a fact. So there was a paper. It was from Suriadi and colleagues. It was from 2017. And it says that the tools from process mining, and this is a big problem in process mining, it's parsing, our data quality indifferent. So if the input parses, the algorithm is producing output. No matter how wrong the input is, there is no built-in warning because the tool has no idea that your log is broken. It can only measure the log against the model. It can't really measure reality here. So the problem with the number is that the number could be false. It could be non-representative of reality. Now, let's talk about the part where you need to really focus. So a defect doesn't just add random noise. So each specific defect forges a specific wrong verdict. And we have 4 definitional possible defects. First of all, you have a real event that is missing from the log. In alignment terms, the model expects that, as you can see here, transition, but the trace can't supply it. So it's charged as a model move, and it's recorded as a skipped activity deviation. So token replay produces the same thing as a missing token. The activity actually in real life happened, but in your log it's not there, so the agent skipped it. So this is the first one. Second one is you have 2 course or tied timestamps. So it's when events share a timestamp, their order become arbitrary, so events get reordered. Meaning that, let's say you have an event because here we're taking the example of course. Let's say we have our timestamps, they are all saying 5 a.m. So it's not, 5 a.m. So it's not precise enough. And you have two events that are happening at 5 a.m. It's very coarse, and now there is a reordering. That can create problems. Here we have what happens when there is a reordering is that we have violations that never happened, and what's worse is that it can mask real violations that actually happened, and with the shuffling they appear that nothing happened, so there is no errors, and that's another problem that you could have. Third defect is what we call the two interleaved runs that share one case ID. So this is the elusive case problem. This is what we call the elusive case problem. Discovery, what happens is that discovery infers directly follows. So you have your DFG that's gonna appear from event order within a case. And when you merge both two runs, you have an invention of a transition, as you can see here, if you read it just here. I can, of course, show you an example, but if you ask an AI, it could generate an example for you here. So it invents its own transition between your activities that actually ran back to back. So there was no transition. You have spurious edges that are coming out of thin air. This is also a very well documented mechanism. Third defect, and this is what we call the same OP renamed across deploys with two labels. So one real activity appears under two labels. The model recognizes one, so every occurrence of the other variant is charged as a deviation. And this happens systematically, of course. This one has named empirical support. It comes from a paper, as you can see here, that appeared in 2024 or 2025, if I'm not wrong. It was about the data quality issue. So all in all, you have same fitness engine, you have 4 completely different defects, and the single number at the end can't tell you which lie you are looking at. So you need to investigate further after this. So your first reflex would be to say, okay, then I'll validate the log, which is a good instinct. But there are two kinds of validation. First, you have actually validators that could work for OCEL 2.0. I actually have a tool to do the semantic checking it's called OCEL for VS Code. And you have many types of structural validation for XML, for your JSON schema, for your SQL constraints. All of these are already present. You have multiple tools that can do that. If you run them, everything that comes back green, well-formed, then you have no problems. But there is another problem of validation that is still not solved, which is the semantic validity. So these are the questions that only when you know the real situation you can truly assess. There is no tool today that can do this for you. So what I'm meaning by that, are any real events missing? Is each event attributed to the right case and the right object? Are the labels consistent over time? These are all questions that are not structural, they are semantic. So no schema validator can do that for you. Now, so a log can pass every OCEL 2.0 schema check, but still contain the 4 defects from the past slide. Now, the semantic checks, the ones that actually protect you, you have to build yourself. These are case-by-case things. For now, you can only do them if you know the real-life situation. So one more thing I wanted to explain here is that you have these two errors are not equally bad. So if we put them on a scale, you have one side your false deviation, and then you have your false conformance. So a false deviation is when the log makes something look wrong that was actually fine. So this is false deviation. So on the other hand, so it costs you a false alarm and some wasted analysis time. So it's annoying but bounded. On the other hand, for false conformance, on the other hand, a real violation that the broken log lets pass silently that ships an unsafe agent. So this is what happens with a false conformance. And it ships it with a clean bill of health. So the cost of shipping an agent like this is unbounded. And you only find out about this when it fails in the wild, like when in production, which can be catastrophic for you. So in governance or audit setting, false conformance is the dangerous error, precisely because it looks like success. And I need to be honest here, this asymmetry is an argument by analogy. From you have alarm fatigue in research and audit evidence principles, so where the missed alarm is far more dangerous than a false one. So if you miss an auditing issue, it's a lot more problematic. You would rather have false alarms than just missing the problem all on its own. So all of this is my own reasoning. Other people could tell you other perspectives on this matter, but the direction is hard to argue with. So the error that hides is worse than the error that annoys you. So what's nice about this problem is that you're not starting from a blank check. You already have catalogs that discuss these different problems. So you have the following paper from Suriadi and colleagues from 2017 and the following paper from Bose and colleagues from 2013. I will not get into details about these papers and the different problems because I want to keep the video short. But what I wanted to tell you is that generally in the field, in process mining, you want to be at 3 stars. So paper trails is basically, you have paper trails, you're scanning them, and then you're entering them into your analysis. So this is the least reliable source of information. After that, you have ERP or your CRM tables. Here, some information might be wrong, some information might be missing. So you still need to do a personal check on your data. Third is your automatic. What does this mean? Is that your events are logged automatically. You think that they are trustworthy, even if they are not complete, of course, but at least you have the feeling, like you have the assurance that they are trustworthy and they are automatically being logged. Fourth is systematic, and you have your case and activities explicit in your databases. And fifth is you have semantic and you have semantics that are checked, and you have your ontologies already established. This is your 5-star level. So you would do only at level 3, of course. Now, how do you know your semantic checks actually worked? So you test them against logs where you already know the answer. And there is actually precisely a tool to do that thing already. The Open Agent Traces Generator, OCEL gen. So what it does is it makes synthetic OCEL 2.0 logs where every deviation is labeled. So you have deviation, it tells you is deviation, basically tells you true or false that it is a deviation or not. If it's bad, a deviation, you get your deviation type. So here, for example, we had repeated activity. It could be wrong tool, for example, as a deviation, and each run carries is conformant, and that's a boolean that says, okay, this run is conformant or not, and it writes out a normative model.json. This is your type of model that you get. So the template here is that each one, you have your template here, which is the normative model, and each one is checked against that. That's your ground truth. Now, separately, there is an IBM research paper, and this one is talking about detecting silent failures in multi-agentic AI trajectories. So here they used OpenTelemetry, and to do the tracing and define its own taxonomy, of course. And you have 5 silent failure scenarios. These were defined as drift, cycles, missing details, tool failures, and context propagation failures. So here, these are your 5 different silent failure types. So these are different. You need to differentiate between these 10 deviation types and these 5 silent deviation types. You need to understand, I do not want to get into details about each deviation type, but this is something you could check. So either way, you cannot always trust your validator. This is the point of the whole episode. Especially if you never tested it. So you need to run it on known bed logs first, where the answer is key, where the answer will where you already know the answer, and that then you will know if your validator actually works or not. So now this is the point of the use case of the whole episode. So under the EU AI Act Regulation 2024/1689, for a high-risk system, your log stops being a debugging convenience and becomes legal evidence. So you could use your logs as legal evidence. This is a very important point. So Article 12 requires high-risk systems to automatically record events, as you can see here. And this should happen over the system's lifetime. Article 19 and 26 require deployers to keep those automatically generated logs for a period appropriate to the purpose. And this period is at least 6 months. And the high-risk obligations under Annex 3, so this is Annex 3, apply from the 2nd of August 2026. Today we are the 15th of July 2026, so that's in 2 weeks and 2 days. So that's very near term, of course. Now, you need to reframe what the log is in your mind. It's not just training data at this point. You cannot just let it be sloppy. It's actually evidence in some systems where you will be actually audited on. And the low quality log is low value evidence. So if you can't show the log is accurate, you could have problems. You can't use it to show how the agent actually behaved. One honest caveat here I need to mention is that the Act mandates record keeping and retention. It does not literally require tamper-proof logs, so that's another level, that's above. And so integrity is best practice and good sense, of course. So just don't quote me as saying the statute demands that your logs are tamper-proof. What the statute actually says is record keeping and retention. So here, don't mix these two sides. Now, to recap the full episode, you need to validate the log before you mine it. That's the first thing you need to do. You have to have a schema that is valid. That's not having valid schema is very different than having a schema that is true. Those are two different things. A bad log will fail silently. That's big problematic, and we have seen the two types of failures, of course. And the number it hands you could lie with total confidence. That's the biggest problem for the results of your analysis. Now, this will be the last episode of season 2. So we went from row spans to span tree, and we captured a stable run ID. We chose a case notion, flattened it into tree in this season, and we had 5 episodes. This is episode number 9. For season 3, this is where it all pays off. So we will be talking about discovery and conformance for real. You have mining the validated. We will be talking about how you mine the validated log. And this time we will be trusting the verdict. So this season was more about how to know if your log was realistic or not. See you in season 3. If you like the content, of course, please like and subscribe and follow me on LinkedIn. Thank you.